Okay, so let's get started with the next in our exciting series of Matlab and Psychtoolbox lectures. So I think we've got everybody set up now on a PC that hopefully has Matlab on it. But like I said, don't try to follow along too much today. I think try to follow what I'm doing is more important. And then I think we'll have some time at the end to kind of practice and mess around and explore the code on your own. So here's where we're at today. So remember last time we talked mostly about Matlab scripts and functions. Today we're actually kind of catching up from what we were going to do last time and just talking about basics of Psychtoolbox. At this point I think we're kind of off any sort of sense of correlation with this original plan, and we're just going to play it by ear each week to see how much we can get through. We may not get to like too much sophisticated data analysis stuff with Matlab. So we probably won't get to some of these advanced topics, but I do want to at least give you a pretty good idea of what Psychtoolbox can do and do a little bit of analysis before we wrap up for the semester. So today we'll do basic Psychtoolbox stuff. I think, so like I said, this problem set you're not doing any Psychtoolbox stuff, but the last couple of problem sets will maybe have you explore some other Psychtoolbox things that we don't cover in lecture, just so you can get used to you know, kind of reading the documentation and figuring things out based on the documentation. So I think, I think we'll still get to some good stuff, but we're probably not going to be analyzing fMRI data or anything like that, probably. But, we'll see how it goes. Okay, so hopefully everyone now has their problem sets back, right? Everybody good there? Problem set 6 and 5 and project proposals. I know those took a long time. Sorry about that, but they took a very long time to mark. And I'm sort of designing this next problem set to not take as long to mark. And also, like, I know that because the semester is a bit compressed, these problem sets are going to be shorter for you guys, hopefully, as well. So that's the good news. I meant to get it up yesterday. It will be up sometime tonight when this podcast is live, and at that point I'll update. I know I need to still update the links to the podcasts, all the files in our class folder. So I'll get all that updated. It'll all be ready by tonight. So that's that. Due date, I will have to sort of look at the calendar and figure out what is a good due date for the difficulty level, but I won't work you guys too hard, especially now that we know that Matlab access may be somewhat limited. So I'll update you on that. Any other questions or thoughts or administrative things? Okay, hopefully people's projects are coming along okay. Like I said, I thought all the proposals were pretty good. So that was good. I had some suggestions for some of you, and I'm guessing most of you are not so far along that those suggestions, undo any work that you've done, because most of the suggestions I did have were like either cut some stuff out to make it easier for you, or maybe add some stuff in to make it more challenging. And both of those, like, would probably, the things I suggested to cut out were probably things that like you would be doing last anyway. So hopefully those suggestions didn't undo anyone's work. Other thing to note is I am going to be working on your exam this week. So the exams are due for me to turn in on Friday, I guess. I have not started yet, obviously. You should know by now that things happen at the last minute. So, we'll see how it goes. We'll see how good a mood I'm in when I'm writing the exam. So, if you guys are nice to me this week, maybe I'll be in a good mood. And if not, no, I'm just kidding. That's going to get cut out of the podcast. I would never suggest that you bribe me. No, but so I'll talk more about the exam after I write it, because then I can tell you kind of what to look forward for, but look forward to. But because it's a written exam, and I think you guys don't generally do multiple choice questions in your final year, so it's going to be short answers and quote-unquote essay questions. But, I'm not going to be able to have you really, or at least when I proposed this, they didn't really like it. They didn't like the idea of, like, writing code, which is, I was going to make you write code by hand, like just little bits, but, do it without being able to check it in software. And they didn't really like that. So it's going to be more about programming concepts and such. And your problem set this time is going to actually be sort of in a similar vein. So hopefully this will be good practice for your exam, this problem set tonight. Okay, so on that note, I only have a couple of slides for you today, but I want to just sort of bring you back to some of the key concepts that we talked about in this class. So if you can recall back to like lecture 4 or 5, we talked just briefly a couple times about the idea of abstraction. We talked about it with regard to like functions and objects and things like that, with the idea being, remember that programming languages and features like objects and such were designed to make your lives easier in programming a computer because, you know, what's really happening on the lowest level is moving bits of memory back and forth, lots of, you know, multiplication and division and various other arithmetic operations happening, you know, millions and millions of times a second. But you don't obviously have to put each of those in by hand if you want to display a picture on the screen. Of course, what you're really doing is moving memory around and making calculations and things like that that are then transmitted to the display. You know, you transmit numbers to the display, and the display translates those numbers into pixels. But you don't have to do that, right? In Python, you would create like a picture object and just tell it to show itself, right? So that's a lot easier. So that's this idea of abstraction, is to, you know, have you working with sort of more abstract concepts rather than the low-level details all the time. And one of my intents in teaching you these two programming languages is not just to stress you out by having to like learn both and get confused about which is which. My hope is that by seeing things from two different frameworks, that would give you a better overview of like general programming concepts and algorithms, so it would help you kind of abstract more. Because I know like when you only know how to do things in one language, you kind of think that that's the way to do things in that language. But you know, there are really another language it might be better to do things a different way. However, on the other hand, for any given algorithm, there's a way to implement that algorithm, generally speaking, in either Matlab or Python or most other programming languages. So what I'm hoping is that you'll, you know, end up with some general knowledge on, you know, how to think through a problem, how to structure the steps of that problem, how to figure out, you know, when you should use loops and if-then statements and like what the logic of programs should be. And you know, people get that to varying speeds. I realize I'm asking a lot and asking you guys to pick this all up, but you know, one of the things I keep seeing over and over on the problem sets is you know, people taking things a little too literally, or you know, clearly you've got code that you kind of pasted in or kind of, you know, glommed together without really like thinking about why it works the way it does. Or when I ask you to explain something, you explain it. Like, a lot of people did this on the last couple of problem sets, so you know, you're not alone. But you know, when I ask you to explain something, you explained like each line of code individually, but you didn't tell me what the overall idea was that the algorithm was trying to achieve. You know what I mean? Like, so if I ask you to, you know, if we look back at one of those algorithms like finding prime numbers or something like that, you know, you can tell me what the program does by saying, like, in this line of code, we set a variable equal to 1. And in the next line of code, we set it, you know, equal to 1 higher. But that's really just translating symbols into English, but it's not telling me what the algorithm is, right? Whereas if I were to tell you an algorithm for finding prime numbers, I'd say, well, start with the number 2, which is the lowest number that could be prime. And then, well, 2 is prime by definition because there aren't any other numbers lower than it to check. But say start with 3 and say, all right, I'm going to check every prime number that I've found so far to see if it divides into 3. And there's only 2 and it doesn't divide into 3, so 3 is prime. Now I check the next highest number, check all the primes in my current list, 2 and 3. It does, you know, divide evenly by 2, so we know that 4 is not prime. Go up 1. So I can tell you an algorithm for finding prime numbers that works in any programming languages, right? I've thought through the problem of finding prime numbers, and I've thought, well, one somewhat obvious algorithm is to check each number, and you know, so start from low numbers and go to high numbers, and at each number, check the list of all prime numbers I've found so far to see if any of them divide equally into that number. And if they do, it's not prime. If none of them do, then it's prime, right? So that's how I want you guys to start thinking about describing algorithms and scripts and so forth. Is like, it's not really as important exactly how well you execute the code. It's more important that you have your thinking straight, right? So I think in the next few problem sets and such, we're going to still focus on writing code, just not in this next one, but in 8, 9, and 10 we will. But again, we're going to try to focus more on getting the concepts right and coming up with new concepts based on things you already know, and less on just the individual lines of code, because it's really slow for me to grade code because I have to paste it all in and make sure it works and look through it. That's really slow. But code's easy to copy. I mean, I know you guys are generally honest, but it's very easy to see somebody else's code and think that's probably the right way to do it. And even if you're not exactly copying them, it's very easy to transmit ideas without understanding necessarily. And code is also easy to fiddle with and get something kind of working, but for no really logical reason, right? So I think it's more important to sort of think through the process. So anyway, that's what we're going to focus on. And again, the point is not to necessarily focus on the syntax of a particular language, right? So how in Matlab, if you have an if statement, you have to end it with an end statement. Whereas in Python, the end of the if statement is implied by indentation, right? That kind of little stuff you can always look up if you forget it. And you will forget it over and over again when you're first learning a language, because you'll sort of want to revert back to the language you know better. But you can always look that up. That's pretty trivial when you're like, oh shoot, I forgot to put an end at the end of that if statement. Okay, now it's there, now my program runs. But not thinking through the problem correctly is a lot harder to solve. So anyway, so all that is to say, you're not going to have to write any code in problem set 7. But I will be asking you to use the Matlab debugger to step through code that I wrote and figure out how it works. And it's going to be a bit of a challenge, but I hope a good one, because I'm sort of deliberately not teaching you everything that you're going to see in these scripts. But the idea is to use the Matlab debugger and sort of look at how variables change throughout the code. And even if you don't know some of the tricks that I use, you should be able to get a sense of what the algorithm is building or what it's doing, even if you don't see exactly how each line of code works. Because with this debugger, what's great about it is you can stop at each line of code and see what all the variables are, and then go on to the next line of code. So you can kind of see how things change and figure out what the algorithms are. Okay, so that'll be the focus of problem set 7. Any other questions or anything about any of that? Okay, so we're going to do one kind of quicker demo and one longer form demo. I wanted to talk just a little bit more about how functions work in Matlab from last time, and then we'll get into some Psychtoolbox demos for the last part of today, and I think you will enjoy our Psychtoolbox demo. So, you guys, if you do have a copy of the demos from last week, I was going to start with just revisiting those a little bit. If you don't, it's not the end of the world. You can just watch along. I'll post all the code from today and the relevant code from the last couple lectures again tonight when I update the Google Drive. So I've done what I've told you not to do, and I've put my code into subfolders. If it doesn't confuse you too much, you can change your directory. So remember when I said Matlab has certain folders it looks in for the files it runs. It always looks in the current folder. So if you keep your folder straight, you can always change your current folder to where code is. And as long as all the code you're running is either a standard Matlab function or something in the current folder, you should be able to run everything. So I've just gone into my subfolder for lecture 12. And if you remember, we had a couple of functions that we talked about functions last time, saying, well, you can have a Matlab script that doesn't have the word function at the top. But it's usually not a bad idea to do that because, again, the idea is you've got these different workspaces, right? Or namespaces, as they're sometimes called. And we talked about this with Python too, where we said, remember that each function has its own namespace, right? So again, I like the metaphor of using a piece of paper is your computer memory, right? So remember when I had you work through problems on paper, I said, all right, well, you write down the variable name and write what its value is, and then every time the variable changes, you update its value. And a namespace is just having different sheets of paper for each function or for your main code, right? So, if you name a variable Bob, if it's on the same sheet of paper, there can only be one variable named Bob on that sheet of paper. And if you update Bob, it changes the value, right? If you say Bob equals 5 or whatever. But if you have a variable named Bob inside of some function and another variable named Bob inside of another function, those are two different pieces of paper. Each has their own thing named Bob that doesn't, they have no relationship between each other, right? And I think some people are still kind of confused about how functions work. From Python, I got that sense from some of the problem sets and such, that people still don't really get how the names inside a function and outside a function work. So that's probably a good thing to revisit, or come talk to me about, or talk over with your friends if that's still kind of confusing to you. But we're going to talk about it a little bit in a Matlab context today. So the thing to keep in mind about Matlab that we talked about last time was Matlab has the same sort of thing where if you have a function here, right? So we said if we put the word function at the top of the file, this turns this from just a list of Matlab commands into a function that other functions or other pieces of code can call. And the difference is that this function, if we put the word function up here, now has its own private namespace, right? It has its own new fresh sheet of paper that all of its names are written on, right? And so Matlab has, you have your own namespace or your own workspace for each function, and then you've got like the sort of communal workspace. So anything that you type in on the command line normally goes in the sort of communal workspace, right? So this is the sheet of paper that everybody sort of writes in by default. So if I say Bob equals 5 here, Bob shows up in this workspace, right? Now, if I call this function, so let's say I wanted to the first thing I wanted to do in this function is display Bob. Is that going to work? Oh, it does, but for the wrong reason. That's a silly little feature of Matlab, is that it interpreted that as a string when I did it that way. So if I do it this way, sorry. So this is saying to display the variable Bob. It doesn't work because it says this is an undefined function or variable, right? And again, that's because this is a function. This function has its own little sheet of paper that all its variables are written on. It doesn't know about the Bob that was defined out here in the workspace, right? Whereas if I take this line out, whoops, and make it not a function anymore, it displays the value of Bob, which was 5, and then it does what it normally would do, right? Okay, so anyway, so like I said, basically the moral of the story is, for the purposes of this class, I'm going to make you guys always save your Matlab files as functions, because you're going to get into less trouble that way, okay? So that's how we're going to do stuff in Matlab. And remember, we said your function name, so this one was called very important number, should match up with the name of your file, right? So it should be the name of the function .m should be the name of the file, because Matlab will, and if I add some characters to that, Matlab's then going to complain and give me an error saying, well, this is known to Matlab by its file name, so it's dumb to call it anything but very important number. Okay, so those two should match. Okay, now there are some finer points of functions. I'll just show you a couple. So if you recall from Python, let's get rid of displaying Bob, first of all, because that's going to cause problems. If you recall from Python, one of the main things we do in Python in a function is we want to return a value, right? Now, you don't always have to return a value, right? This function currently does not return a value. It prints out something on the screen, but it doesn't actually return a value to the function that called it, right? Or to the code that called it. But usually, well, not usually, but at least a good portion of the time, when you write a function, what you want is for that function to calculate some value or create a list or something like that, and then give it back to whichever code called that function. And so we haven't seen how to do that in Matlab yet, the way that we have in Python. And it works a bit differently, okay? So I'm just going to show you this for now. You won't have to do any of this on the problem set just yet. So we'll kind of ease you into it, because I know this is going to look confusing at first. And I actually also haven't shown you how to how to give arguments to a function. So maybe I'll show you both of those, and then we'll go on to Psychtoolbox. So if you recall the point of this function last time, right? It's to calculate the very important number 42 by kind of a silly method, which is by multiplying, what is it, the prime numbers, the first three prime numbers that are defined by a power of 2. So like the first, second, and fourth prime numbers, which are 2, 3, and 7, if you multiply those all out, you get 42, okay? So that was kind of our silly example to generate the number 42 last time. And what we did before is just print it out on screen, right? But if I wanted to use that value in some other code, just printing it on screen is not very helpful to me, right? So I might want this function to actually return the important number to whatever code called it, okay? So let's get rid of this display line, because we don't want to print it out. Let's say we have some big long program. We don't want to print out all the output. Now we have to figure out how to give this number back to the code that called it. So what you do is whatever variable or variables you want, and this is sort of weird, so just look at how I do it and then we'll talk about it. Whatever variables you want to return to the function that called this function, you put between the word, so the first thing that goes on the function line is the word function to indicate that this is a line defining a function. And then you put to the left of an equal sign the variables that the function very important number is going to return. Okay? So in this case, we're going to return the variable important number, right? Because important number is going to end up containing 42. Now the weird thing about Matlab compared to Python, in Python what you would do is you wouldn't have this at the top, right? But what you would say at the bottom is something like return important number, right? So that's not what you do in Matlab. There actually is a return statement in Matlab, but it works a bit differently, so we're not going to learn it. In Matlab, the returning of a value to the function that called it is done implicitly, meaning if you say up here that you're returning a value, you're also giving that value a name. And you're basically telling Matlab, somewhere in this function, I will define a variable called important number. And when the function runs out of code, which it will after line 9, that's the number that gets sent back to the code that called this function. Okay? So let's see that in action. So now I have a function called very important number. And if I want to call this secret of life, universe, and everything equals very important number, I just created a very long named variable with the value of 42, right? So the very important number function calculates some important number, and then when it gets to this line, at the end of line 9, it's done, and it looks back at its, we call this a function declaration. It looks back and says, all right, well, I'm supposed to now send back important number, which I calculated down here. Now I send that back to the code that called me, and so whatever very important number calculates gets assigned to the secret of the life, universe, and everything, and secret of life, universe, and everything becomes 42. Okay, does that kind of make sense to people? It's a little weird because, like, you don't ever explicitly say to return things, and the line where you define the value of important number does not have to be the last line of the function. So, you know, you could say like some other number equals important number times 10, right? And if I run this line of code again, still secret of life, the universe, and everything stays 42. Even though we've just calculated the number, some other number, after we calculated important number, it's still the variable important number that gets returned to the function or the code that called it. Okay, and if you actually look, you see that MATLAB's given me not an error, but a warning here about this code, and it actually is telling me, well, this is kind of useless code, which it is, because this variable is never actually used, right? Because it is not returned at any point, some other number is not, right? It's not returned to anything, and it's not used in any calculations after this because this is the last line of code in the function. So MATLAB's smart enough to tell me that this is actually a useless line of code because this variable is never used, which is kind of helpful actually, right? So usually, if you're returning a value, usually the calculation of that value is one of the last lines in your function, although it doesn't have to be, right? Like, so this would be, if I wanted to both calculate it and return it and also display it, I could certainly put the printing of that information after, well, I would have to put printing of the number after I figured out what the number was, right? So it doesn't have to be the last line of code. So if I do it now, it prints your output as 42. It still assigns 42 to this variable called secret of life, universe, and everything. Right, so it returns this number. Okay. So that's how you would do outputting a single variable. So let me show you, if this hasn't blown your mind too much, actually let me give you another example that's both simpler and more complex at the same time, so that you can see how to send arguments into a function also. So you've noticed very important numbers of function with no arguments, right? And in Matlab, if the function has no arguments, you don't have to put those little, parentheses or round brackets after it, like you do in Python, right? So in Python, whenever you refer to a function, you have to put parentheses or round brackets after it. In Matlab, you can just call it by its name if you don't have to send in any arguments. But let's define one function where we do have to send in arguments and see how that works. Okay, so let's do a function called, this will just be a super dumb example to make things simple. Let's call it sum and product. Because what we're going to do here is two things actually. So we're going to take in two numbers, first number, second number. And we're actually also going to return two things. We're going to return both their sum and their product, okay? And I'll show you the notation and then I'll explain it a little bit. First number, second number. Okay, so what did I do here? First, and then I'm going to save this. And you notice that nicely it suggests saving it as sum and product.m, which is exactly the file name it should have. So that's good. So what this notation of this function basically says is, here I've got the name of the function, sum and product, okay? And you put in two things which are going to get the variable names first number and second number, okay? And what it says is it's going to return two things. And this is what's a bit funky is, remember in Python, we could really only return one thing, right? And this is kind of a strength of Matlab as opposed to Python. Now in Python, the way you get around that is you return one thing, but that thing is like a list, so that you can then unpack that list and get at the individual pieces of it. But in Matlab, you can return as many things as you like without having to have any of them be, well, again, in Matlab, everything's a matrix, really, but you don't have to explicitly like form things into a list. You can just have a bunch of variables inside your function that all get returned to whatever called it, okay? Oh shoot, sorry, I totally screwed this up though. I don't want to return, sorry, ignore what I did. Let's call them my sum and my prod. Sorry, I wasn't thinking. Okay. So basically what this says is I am promising my function that I'm going to create two variables called my sum and my prod. And those are going to be what's returned to the calling code whenever the function returns, okay? So it's obviously pretty easy to do these calculations. So my sum would just be first number plus second number. By the way, notice that this is a line of code that is exactly the same as it would be in Python, with the exception that I end it with a semicolon so it doesn't print the output of that statement. And my prod, I can't type today, equals first number times second number. Okay, and that's it, right? So I've calculated my sum and my prod, and let's see if that works. So the way I get this output, again, you notice that when I only had a single output before, I just did it the same way I would in Python, basically, where I just said some variable equals the name of the function. Again, the only difference is I didn't have to put the parentheses in. But if I want to get two outputs from a function, I can do it this way. So I use these little brackets, which we've seen before to define matrices. This is using them in a slightly different way, these square brackets. So I'm going to say, like, let's just call the sum and the product S and P, respectively. So S, P, and you can either put a comma in between them or not. Matlab recommends you put a comma in. So S comma P equals sum and product. And let's do the sum and product of 6 and 7. And you notice one super nice thing about Matlab is if it finds the function sum and product, it tells you what sum and product is expecting in this little pop-up, which is kind of nice. And it reads that off of the first line of your file. So what this should in fact give me, let's see if it does, S should be the sum, which is 13, and P is the product, which again is 42, right? The product of 6 and 7. So that's what that does, right? So does that kind of make sense to people? I mean, this is a super quick tour through this, but the main difference from Python is just the notation and the fact that you can return 2 variables instead of 1, and that they are both returned implicitly, right, without a return statement. Now, the problem with this implicit returning of values is, let's say you have a typo, or let's say you just decide to change my prod to my product because you decide that that's a better name, but you forget to rename the function declaration. Then if I try to run this line of code again, it says there's an error. Output argument myProd was not assigned, and what that basically means is you never created a variable. Like you promised when you defined the function that you would define a variable called myProd and return it to another function or another piece of code, but you never created it, right? So if I just update this to be myProduct, then it should work again. Okay, so now no error, right? Now there's another few weird things about Matlab, and again, this is just an overview. We'll do it more later, but this is to get you familiar with the kinds of things you're going to see. In Matlab and in Psychtoolbox, in a sense, all function arguments and outputs are in a sense optional, okay? So what that means is, like in Python, you remember that the inputs to a function were sometimes optional, right? And in Python, you could do that different ways. Remember, one of the ways that I think is kind of confusing is that you could refer to it by what the name of the variable was inside the function. In Matlab, you can't do that. You have to always provide the inputs in order. But there's no particular requirement, at least of the Matlab programming languages, that you send in anything into sum and product. Okay? So, in other words, if sum and product, there are ways, and we're not going to make you write any code like this, but there are ways for the function sum and product to determine how many values someone sent in, and adjust its behavior based on how many values you gave it. Okay? So you're not going to have to do this, but as you'll see in Psychtoolbox, there are going to be a lot of optional arguments in Psychtoolbox functions. And basically the rule of thumb is you will actually have to provide some of them, right? Because this function won't work if you don't send in a number because it relies on these numbers, right? Well, actually, okay. Let's do a quick example where you could have an optional third argument. Print output, okay? So this third argument could be like a true or false value that indicates whether to print the output, okay? So we could add some code like if print output, meaning if print output is the value true. Remember that all if statements have to have an end at the end. We could say display sum is my, let's see, int to string. I think we did this before. My sum. Oops. And display product is, you don't have to exactly understand what we're doing here, but we're basically joining strings together as matrices, as we did a couple classes ago. All right, I screwed up somewhere. Oh, no, I didn't. Okay. So if we now say sum and product 6, 7, true. Oops. Oh, typo. There's no such thing as in toStir, but there's an int toStir. All right, so now you see that if we send in true, it prints things. If we send in false, now why does it do that? Oh, what did I do wrong? Oh, I only typed in false. Sorry, I'm dumb. I meant to replace, sorry. All right, yes. If I send in false, it doesn't print the output. Okay, so that's adding in a third variable, but let's say we want to make this optional, right? So if you don't tell it to print the output, it just doesn't print. So one thing we can do, and you guys don't have to learn how to do this, but I'll show you how Psychtoolbox and other things do this, is every function has kind of a secret variable or function called nargen, or nargen, which stands for the number of arguments that were sent in. So we can say if nargen is less than 3, which basically means if we didn't specify print output, if we've only got first number and second number, print output equals false. So what that's basically saying is this is how you would provide a default value. Remember in Python we said that, well, if you don't specify certain arguments to a function, it has a default value. We didn't show you how to specify them, and Python does it a bit differently. But in Matlab, this is how you do it, is you explicitly check to see how many arguments the function has, and if it has less than a certain amount, you just redefine, define what the variable is. So now, if I don't put in anything at all, it doesn't print, right? But that's very important that we put that in, because if we don't check that and we don't send anything in, then it gives us an error saying not enough input arguments, right? Because if I don't explicitly check to see if someone provided this, and I just use it assuming that they did, this print output argument, then that's an error, right? But if I check to see if they provided it first and give a default value if they didn't, then it's totally fine to only put in 2 arguments, right? Okay, so I know that was a super quick overview, but this simple function here with 12 lines of code kind of gives you the whole overview. Oh, actually, one more usage case I'll tell you, but this function kind of gives you the whole overview of how function definitions work in Matlab. For the most part, there are a couple other fine points that you'll never have to learn. The other one fine point is, like I said, all the output arguments are actually optional as well, sort of. So let's say I have this function sum and product, but I only want the sum, and I'm too dumb to use the plus sign for that for some reason. If I only want the sum, I can just say, let's call it just sum as my new variable, equals sum and product. Whoops, and product. Let's get the sum and product of 12 and 17. I'm tired of the others. Okay, so now I made a variable called just sum, which is 29, which is the sum of 12 and 17. But that other output value, whatever the product of 12 and 17 is, it just vanishes, right? So Matlab is smart enough to know that if you only provide one output, you only want the first one. Now, if you only want the second one, it's a bit trickier, because basically Matlab assumes that the leftmost outputs are the most important ones. So if you want only the second one, you'd actually have to use kind of a funky notation like this, where you put a little squiggly tilde mark. And that just basically is sort of a null output. Sum and product 12, 17. So that creates the variable just product, which is 204. And it doesn't assign the sum to anything in particular, okay? Now what I do when usually what I do, and this is not always good coding style, but I don't actually use these little tilde things. I usually just assign everything to a, I'll just go ahead and get the sum, even if I don't use it. But what you'll find if you look up a lot of functions in Matlab is that there are a lot of different usage cases. Like if you look up, what's a good, I want to use one that, okay, so let's make a random matrix called, let's call it mat1 equals 5, 3, 1, 2, 4. And let's call it stir1 equals equals E, C, A, B, D. Notice that I use the first 5 numbers and the first 5 letters of the alphabet, right? So if you want to look up a function, like there's a function called sort in Matlab. If you look up the help and sort, it'll tell you some things, and one thing it'll tell you is there are different usages you can use. So in this case, you would only ever give, well actually that's not true, so you could just say sort whatever and just put one thing in, and what that puts out is an output of the sorted thing. So for example, if I want to sort matrix 1, right, it was this, and the sorted output is 1, 2, 3, 4, 5, right? But it also tells me, all right, I can do kinds of some other things like there are 2 optional parameters. Dim is a dimension along which to sort. That just means if you have a 2D matrix, you can sort by the columns or the rows, but we don't really care about that. But if I wanted to sort in descending order instead of ascending, I could do that. And I think, let's see if this works. Oops. Oops. Oh, no, okay. Sometimes you can get away. You'll see this in Psychtoolbox. If you don't want to provide a value for something, you can provide an empty matrix, and that basically means ignore this parameter, but not always. So in this case, it looks like I have to provide. So this will be along dimension, that's actually dimension 2. But anyway, so I can use sort with either 1 or, in this case, 3 inputs, right? And I can get multiple outputs. So let's say I want to say, so mat1 is still my unsorted version, right? So if I want to say mat2 equals sort mat1, so now mat2 is equal to the sorted version of mat1, right? But let's say I wanted to sort my alphabet letters in the same way that I sorted my mat1. So ignoring for the moment that I could just also sort that directly in alphabetical order, one thing that that the sort function does is it also gives you, if you provide 2 outputs, it also gives you what's called an index matrix, which just basically means it tells you which items you need to access in which order to get the sorted version. So let me just show you, and then you'll see how that works. So let's say mat2, I'll call it ind, equals sort mat1. Now mat2 is still the sorted version of mat1. Ind is this. So basically that was saying that in mat1, which I'll display up here, what ind is saying is the first thing in the sorted version is item 3 of the unsorted version, right? So mat1's item 3 is the number 1. I'm realizing I should have used something other than 1, 2, 3, 4, 5 because this is super confusing. The second thing to go in the sorted version is the 4th thing of the original matrix. The third item to go in the sorted version is the second one in the original matrix, and so on, right? And so that's nice because then I can just use those indices if I want to say string 1 and use those indices to access string 1, I get a sorted string. Now that's a little bit of Matlab trickery that you don't have to know yet. The point here is just that sort is a good example of a function that has, in its very least form, you only have to give it one thing and it returns a sorted version of that thing. But you could give it up to 3 things if you wanted to tell it to sort in a different direction, like sort it descending instead of ascending. And you could get out of it up to two things, which could be the sorted matrix and the indices of the things that you wanted to sort. Okay? All right, so that's probably a little bit too much information for now, but the take-home points are just you can have multiple inputs and outputs. In a sense, they're all optional, which will come into play with Psychtoolbox in a little bit, and what else? And just basically how to define these things. So again, you won't have to do this just yet, but hopefully when you see a function definition or function declaration, you won't freak out too much when you see a line like this. And again, you'll get more familiar with this as we go on. Okay, so any questions on any of that so far? All right, so let's resume here and do some actual Psychtoolbox. So as with PsychoPy, the documentation is really going to be your friend with Psychtoolbox. Again, the downside of Psychtoolbox is it's not quite as user-friendly, I think, as or it presumes a little bit more programming knowledge than PsychoPy really does. So the documentation can be a bit hard to read sometimes. But what you're going to really want is the function reference. I think it's docs.psychtoolbox.org. Usually you'll find it by just Googling like Psychtoolbox and the name of the function you want to call. So it's got a pretty good documentation that's pretty accurate and up to date. And I use this all the time because I can never keep straight how everything is used. All this information is actually kind of in Psychtoolbox already. If you do so what you'll soon find is that about 80% of all you do with the display is actually done through one Psychtoolbox function, which is called screen. The screen function is crazy important. So we'll be spending a lot of our time on the documentation for screen because what screen is actually kind of a mega function that does a bunch of other things. So you can tell screen to open a window, close a window, draw lines, draw arcs, fill rectangles, fill ovals. It can put a picture on the screen. It can draw a texture, which is basically an image. Screen is what you use to flip. So just like we flip in Psychtoolbox, use screen to flip. So use screen for lots of stuff. So you spend a lot of time on your screen documentation. So screen's sort of a weird special function that way. It kind of handles really everything you do with the screen. But if we, so if you look at the documentation for that, you can also get that in Matlab by typing help screen. But it's a lot harder to read this than it is to read a nicely formatted web page. So I recommend the website personally. Okay, so we'll go back and forth with the documentation a little bit as we write up this demo. So this is just to give you an idea of some of the stuff that Psychtoolbox could do. I thought we could go back to our number guessing demo, but that's kind of boring. So let's just do a purely graphical demo, which I'm just going to call PTB, which is my abbreviation for Psychtoolbox, smiley demo. We'll use that old smiley face image that we used last time. So we'll see how far we get with this, but the basic version of this, I wanted to just write something that'll put an image up on the screen, and then maybe we can move it around or something. So let's start with it in its most basic form and then go from there. So one of the first things we'll need to do, just like in PsychoPy, I recommend putting kind of all your global settings at the top of the script. So create a variable called file name that holds the name of the file name. And you'll see, I'm going to go ahead and save this. Except, I'm going to actually move that out of the Lecture 12 folder because I have the other files in the main Matlab folder. So let me just actually quickly do that. So just to mirror you guys. So you can see what I've got in my main Matlab folders. I've already got smileyface.png in there. Which, just like PsychoPy, you're going to need the image to be in the same folder, or at least be able to tell Matlab what folder it is in. But for simplicity's sake, let's keep them in the same folder. And there's actually a couple of functions that I'm going to provide for you guys. These are things that I wrote, to do things like initialize. I wrote a function called PFP PTB init, which stands for this class, Psychtoolbox initialize. You kind of have to call this to start Psychtoolbox going, and then a function to clean it up at the end. And so again, that's something you don't really have to do in Python, because when you start the script, PsychoPy knows to like initialize itself and to clean itself up. But you'll see there are a few occasions where you're definitely going to need these. And there are a few occasions where Psychtoolbox can get a little crashy on you and you really need them. So we'll get to that in a second. But these have some kind of complicated code in them, so I'm not expecting you guys to know what they actually do, really. I mean, we can kind of step through them, but it's not too important right now. Okay, so I'm going to open up my Smiley demo again. So one thing we'll need to know is our file name. And what I'm going to do is I'm going to put it up on screen for a certain number of frames, just because we don't know yet how to do keyboards and stuff like that. So let's say number of frames, just to start off, because we only need it up for a couple of seconds. Let's say like 5 seconds would be 300 frames at 60 frames a second. So I'll say 300 frames. Let's just put the picture up on the screen at first. So I'm going to put a little comment that says that this is the end of general settings. When we get a little more complicated, we'll add some other stuff up there too. But let's get into the actual code. Okay, so the first thing I'm going to do is say my image equals, this is a Matlab function. And again, I'm going to distinguish between built-in Matlab functions and Psychtoolbox functions. So one way you can tell the difference is that Psychtoolbox functions are always capitalized, and Matlab functions, with maybe one or two tiny exceptions, are almost never capitalized. So if it's all lowercase function, it's a Matlab built-in function. If it's capitalized, it's part of Psychtoolbox. So imread is a Matlab function for reading in a file from a picture. So I'm just going to say imread my file name. And what that's going to do is it's going to read in that PNG file, and it's going to put the image information into a matrix called myImage. You don't exactly have to worry about what's in myImage just yet, but it's numbers representing the image, basically. What else do we have to know? Well, we're going to have to know, actually, let's see. We won't have to know too much else just yet. So let's just call this PFP PTB init. And the important thing to know about this is basically this PFP PTB init returns two things that you're going to want to keep, which are a window object and the rectangle defining basically the window screen. So it's a little bit similar to, we can open it up and I can show you what it does, but most of this is not going to make a lot of sense to you guys. It does a bunch of things, and this is again one of the downsides of Psychtoolbox is you have to do some low-level stuff that you don't have to worry about in PsychoPy, but you do get a lot more control. So you do some things like you have to check to make sure your graphics card is compatible, which you do with this OpenGL call. You do some things that you don't always have to do but are nice to do, like let's see. Well, there's a bunch of other things that we do, like set your Matlab process to the maximum priority on the system so that Matlab can run as fast as possible. The main thing it does is check to see how many screens you have. We're generally just going to have one screen, and check the current resolution of the screen. And it also does things like hide the mouse cursor, tells it, for right now, we're just going to always set our screen to that default medium gray. Opens a window on the main screen and saves a variable corresponding to that window, and that window's rectangle, meaning you know, what the coordinates of the left, top, right, and bottom are. And it does some other things like set the default text size, and it uses this to say that if someone presses keys that they don't get sent to the Matlab window, so that like when someone's pressing keys during their tasks, you know, all their key presses don't show up in your Matlab, which is a bit annoying. So it does a little stuff like that. The main thing that you need to know that it does is it creates a window and it checks your resolution. Okay, so what it gives you that you're going to care about are basically a variable for your window that you're going to need when you draw something, because you need, just like with PsychoPy, you need to tell things that draw stuff which window you're going to draw to, right? Because you could have multiple windows. This window rectangle is useful sometimes if you want to know what the boundaries of your window are, and we actually will want to know that a little bit later. Okay, so one other thing we're going to have to do, which we don't normally have to do in PsychoPy, is turn this image file that we've read into what's called a texture. And if any of you guys are big gaming nerds, this will kind of probably make more sense to you. So Psychtoolbox actually, well, and PsychoPy as well, they use your graphics card to display what's on screen, right? And graphics cards for games and such are really good at generating polygons, right? Like, shapes and stuff for 3D type games. But they also do flat things, like just flat images, right? And basically a graphics card refers to any flat image as a texture, right? Because the idea is if I have some building or something that's like a 3D model with 3D triangles and stuff, I can take an image, like if I want that wall to look like brick or stone or something like that, I take a little image of brick or stone and apply it to that 3D structure, and that gives the texture on that, right? So the reason it's called a texture is because all 2D images to your graphics card are treated as textures on a flat surface. The only reason that matters is to know why the name is what it is. Okay, so what we need to do for easy input to your graphics card, and this is what makes Psychtoolbox really, really fast to draw with, is that it talks directly to your graphics card, is we need to turn this image into a texture. And for your purposes, you don't really need to know what a texture is besides that. Just kind of take it for granted that what we need to draw with are textures, not just the image information. So let's call it my texture, and we do this with that universal screen function. So that we're on the documentation for screen, and one of the many subfunctions of screen is called make texture. So if we look at the documentation, it returns what's called a texture index, which is just a way to refer to the texture. And what you give it is you have to call the screen function. The first argument has to be the string make texture, because that basically tells the screen function which of its subfunctions to do. And then you need to tell it what window you're drawing into, you need to give it the image, and then there's a bunch of other stuff that you can also give it. That's indicated in these brackets to indicate that they're optional. So we're just going to give it the window index and the image, and to tell it to make a texture. So we do that by saying screen make texture. First thing we tell it is the window, and then we give it the image, and that's enough to make a texture. Okay. By the way, I don't suggest anyone actually run their code until I give you some extra. Well, you're not going to be able to run the code until I give you these PFP PTV init files, because again, it's problematic when Psychtoolbox crashes. So I'll show you this. So don't worry about running the code. Although if you want to type it in, that's cool, because it's good to sort of just get your fingers used to doing it. Okay, so I think that's pretty much all. Let me just see. So the other thing we're going to be doing is we're going to be using a screen subfunction called draw texture. So let's go back to the screen documentation. I mean, I know what the eventual code is going to be, but let's do this like we're writing it for the first time. Okay, so draw texture, again, needs a window and a texture, and then it has a bunch of optional stuff like what part of the image to draw, where to draw it into the window. For like super basic, just getting this working, let's just draw it right in the middle of the screen, which is the default. So I'm just going to add in a couple other things to indicate when it draws and when it doesn't. So just like Psychtoolbox, if you flip the screen, which you do with the flip command or subcommand of screen, without drawing anything into it, it gives you a blank gray screen. So I'm going to flip it once just to clear out the gray screen. And then I think I might have told you guys about these functions. The functions for timing in Psychtoolbox have great names. This one is waitSex, and if you want to know what the current time is, you ask it to getSex for you, which is a helpful thing sometimes. So just to distinguish between before and after I start drawing the smiley face, I'm going to make it wait 1 second. before drawing so that you guys can see when it actually draws the face to the screen. So I've flipped it so it should be nice pure gray. I'm going to wait 1 second, and then what I'm going to do is, this is a little wasteful for drawing a single image, but we're going to do it this way because in a minute we're going to animate the image. So we're going to go ahead and get the framework for that now. So we're going to use a for loop for, let's call it for current frame equals 1 to n frames. I don't think we've really talked too much about for loops yet in Matlab, but this is how you would do a for loop in Matlab. Basically what this means is the variable called current frame is going to take on the values between 1 and n frames, which is 300, right? So this is the same thing that you do in Python with the range or x-range functions. In Matlab, you just do it with 1 colon n frames, right? So now if you wanted it to go from 2 to n frames, the 1 could be a 2, it can be anything, right? So this just loops from 1 to 300 and puts the current value of the counter in the variable named current frame. And what we're going to do each frame for now is just use the draw texture subfunction of screen. So remember, we give it a window pointer, or a window variable basically. So my window, and then give it a texture, which is my texture. And that should be enough to draw it to the center of the screen. And then we're going to flip the screen. So again, remember, the function is not called flip. The function for almost any drawing operation is called screen, but then the first thing you tell it is what subfunction of screen to do. And again, this gets into like complicated implementation stuff, why you use the same function for everything. So don't worry about that right now. Oh, and you have to tell it what window to flip. So that's going to be my window. Okay, now if you look at the flip function or subfunction of screen, let's go back to the main screen documentation. I'm going to open this in a new tab because we use this all the time. So let me just, where's flip? Okay, so let's keep the main screen documentation here. So flip can do a bunch of things. Like you can tell flip exactly when to flip, which is kind of nice. But for right now, we're just going to use the default again for flip, which is, what that basically means is flip on the next frame possible. Okay, so if we draw something, then flip, basically this is going to have it draw every frame. Okay, so what we should get is 300 frames of a smiley face just sitting in the middle of the screen. And this is giving me a warning because it's saying the window rect might be unused. Matlab likes to warn you about things like when you don't use a variable, but we are going to use it eventually, so I'm just going to ignore that for now. Okay, so let's do the PTB smiley demo. This is something that PTB init does, is tells me what my current resolution is. If you're running an experiment, this is helpful because oftentimes you want to make sure your screen's set at the right resolution. Hopefully this doesn't mess up the podcast or anything again. Okay, so we've got it in the middle of the screen. Now, there's a small issue, which is just that the background of the smiley face is black, as you see. That's basically because this is a transparent image, and I'm not going to show you guys how to deal with transparent images right now. So it makes the transparent background of, remember, like on Python, it accurately handled the fact that the background of the smiley face was transparent, right? So, oh shoot, you know what? This is going to stay up forever now because I was dumb. So the script is actually done. I was wondering why it took more than 5 seconds. But I did not foolishly tell it to close the window. So this is one problem if your script crashes, is that you can't use your computer, right? I'll show you what to do in that case. But anyway, finishing up the transparency issue. So the reason it's black around the smiley face is because you have to explicitly tell Psychtoolbox and Matlab how to handle an image that has transparent pixels. By default, it just makes them black. So we're just going to let them stay black for now. Now, how to get out of this weird crash state? One very helpful thing to know about Matlab is generally to stop anything that's running. If it's like gone out of control or whatever, you can hit Control-C. Often you have to hit it a bunch of times. Control-C is key. In theory, if you've got a frozen script, that should kill it. And then what you have to do, there are a few things you can type. So in theory, what that should do is stop your script and it would put your cursor back on this command line, although you still can't see it. One really useful command is to hit type SCA, which is shorthand in Psychtoolbox for this function of screen, which is close all, which basically means close all my windows, close all my textures that I've created, basically clear out everything, which lets you get your screen back, right? So SCA is super helpful. It's also part of PFP PTB cleanup. So I suggest you run that too, because basically that clears out all the memory and everything that, that you allocate when you start using Psychtoolbox. So really what I should have done was, at the end of this task, call PFP PTB cleanup. And then it will actually run for the 5 seconds it's supposed to, and then clear itself off the screen. So let's see, 1, 2,000, 3,000, 4,000, 5,000. Okay, good, right? So that's what it does. Okay, so fascinating stuff so far, right? That's good, actually. I was going to deliberately program in a bug so you guys could see. Well, I can still do it. So let's say we have some bug like that produces an error. So if you want to force an error to happen in your code, you can use the function called error. Some error happened. So you'll see what, well, let's actually do this inside our drawing. So right after we flip our screen for the first time. So if you got an error in your code, what would happen is something like this. So unfortunately, you can't see the error message. If I have my volume turned up all the way, let's do this again. Let's do my cleanup, do the smiley demo again. This is a good reason if you don't have sound in your task to do your Matlab programming with the sound turned all the way up. Because at least then, I don't know if you guys heard that, at least then you get your error beep when there's an error. Otherwise you might just be like, why is it still sitting there? Why isn't it going away? So that is one small problem with this code, but just get into the habit of hitting Control-C a few times and then typing SCA to get your command line back, and then you can do your cleanup. I know that's a little bit annoying, but what you gain is a lot of power. So I'm going to demonstrate that programming power to you, and hopefully that makes it worth some of these little inconveniences of having to deal with all this low-level stuff. Okay, so let's make this image actually do some stuff to show what we can do with this drawing operation. So let's get rid of our intentional error that we threw. So the first thing let's do is let's make this smiley face move around the screen, okay? So we're going to need to define some new variables to do this, right? Because we need to tell it how fast it's going to go. So I'm going to set my velocity to 3 in the x direction. So that's going to be how many pixels per frame it moves from left to right. And I'll give it a separate y velocity. So I'll do that. So that'll let me move this image around at different speeds in the left and right directions and the up and down directions, right? So let's do that. Let's increase the number of frames to like 1800, so it'll do it for a few more seconds. Well, let's see. Let's do it for 10 seconds. That's 1200 frames. It's good to know how many frames a second your screen is. Okay, and now what we need to do is we need to figure out a way to move this image around the screen 3 pixels each time. So let's, we're going to need to know a couple of things to do this. So if you look back at the documentation for draw texture, oh, that's good. That's great. I'll speak really loud between the computer fan and the power washing going on outside. So if we look back at draw texture, we saw that we can choose what rectangle. Basically, again, this is a thing that's a little bit different how Psychtoolbox handles it. Psychtoolbox likes you to specify exactly which rectangle of the screen you're going to be drawing an image into. PsychoPy would let you just specify an x and a y coordinate, and it would center it at that coordinate. But Psychtoolbox wants you to give the entire rectangle. And this is a good thing to know. Rectangles in Psychtoolbox are basically just matrices that have 1 row and 4 columns, and they're the pixel locations of the boundaries of the rectangle in terms of its, well, I'll do it backwards. So it's left boundary, top boundary, right boundary, and bottom boundary. But I'll show you kind of how to do that. But basically the idea is if we want to move this thing around on the screen, we have to keep giving it different rectangles for where it's going to be drawn to, okay? So there's a couple ways we could do that. The first thing that we'll need to do is we'll need to get the size of the image to know, because you also have, if you're going to give it the destination rectangle, you also have to give the rectangle defining the image, which in this case we want to just use the whole image. So if we want to get our image's size in X, well, let's do our image size in Y first. We're going to use a Matlab function called size. I'm going to ask you, I think I'm going to ask you some questions about size in the problem set. I haven't quite finished that part, but so I'm not going to tell you exactly what we're doing here, but it'll get the size of our image in pixels in the X and Y dimensions. So that'll do that. So then we'll make our window, we'll make our texture, and then what we will want to do is, let's see, let's make another variable called image rect for rectangle, and that's just going to be 0, 0, image size X, image size Y. Okay, so like I said, rectangles are basically 4-item matrices, left, top, right, and bottom. And basically, again, this is different from PsychoPy. So in PsychoPy, this is the center of the screen is 0.00, and you go negative and positive like you do in algebra. In Psychtoolbox, the upper left part of the screen is 0, 0, and you count pixels to the right and down, okay? So 0, 0, so like 0 is the left edge of the image, 0 is the top image here, or top of the image here. The image size in X would be the far right of the image, and image size in Y would be the bottom of the image, okay? So that's left, top, right, bottom. That's just saying use the whole image, or here's a rectangle defining the entire image. And then what we're going to need to do is, let's see. Oh, okay, actually, that should be, oh, right. I sort of lied to you a little bit because I forgot what I was doing. So we're actually not, well, we are telling it to use the whole image basically, but we actually don't need to specify. So we could specify just a sub part of the image, like a sub part of the rectangle, but we're actually going to leave that one blank. What we really care about is where we're going to draw on the screen that rectangle. So what we're doing here is basically setting up just a rectangle that is the same size as the image. But what we're going to do in a second is we're going to center that rectangle on a particular point when we draw it, okay? So to do that, the first thing we have to do is create a couple more variables representing our X position. And to do that, we need to know some things about our screen size. So we need to do a few more things, create a bunch more variables. So one thing we'll need to do is figure out the minimum and maximum coordinates on the screen because we want our image to appear within the screen. So remember when we got that window rect, when we created a window? We're going to use that now. Window rect 1. So remember the first element in a rectangle is the left boundary. Really in a window that takes up the whole screen, you know it's going to be 0, but because basically this is pixel 0 is the left edge of the screen, but we may as well do it this way. So the maximum X coordinate is going to be the third element in the window rect, right? Because again, it goes left, top, right, bottom. So the third thing is the right boundary, which is the maximum X coordinate. Y min is window rect 2 because that's the top, and Y max equals window rect. Don't worry if you're not getting all this. I know it's a bit complicated. This is just to kind of demonstrate what you can do and how, in a way, it's more complicated, but when you kind of get some of the basics down, it's more powerful too, I think. Okay, so then what I'm going to do is calculate what my resolution is in X, or my, how many pixels I have to work with, which is just going to be the maximum pixel value minus the minimum. Y res is going to be Y max minus Y min. Okay, so that's going to tell us. So basically, if I'm running it at 1024 by 768, X res is going to be 1024, Y res is going to be 768. And all of that is going to let us calculate a position, which I'll call X pos, which will be a random number. So rand by itself in Matlab gives us a random number. You can also do it, again, without the parentheses, but I think it's a good idea for you guys when you're calling a function without any, that doesn't require any parameters or arguments. I think it's probably good that you get in the habit of using the parentheses so that you can tell the difference between functions and variables. So rand will give me a random number times the X resolution plus the X min. So that will give me a random pixel somewhere on the screen in X, and the Y position will be rand times Y res plus Y min. Again, we can spend more time next time breaking this down and kind of explaining it. This is just to kind of get you familiar with the sorts of things you would do to get these scripts working. Okay, and we've set up our image rectangle already. So what we're going to do each frame when we draw it now is, before we actually draw the texture, we're going to redefine our image rect as a new rectangle on the screen. And there's a nice little function in Psychtoolbox called center rect on point. I won't bother to find it for you in the documentation. So like I said, PsychoPy will center for you automatically, but it's not too much of a pain to do it in Psychtoolbox because they give you this function, which basically says, give me an XY point and a rectangle, and I'll give you a rectangle that's centered on that point. So I'll give it the image rect, and the X position, and the Y position. And then what we're going to do is change our draw texture line. So remember, source rect, we said we're going to leave empty, basically the third parameter here. Just going to make this more readable. Because we want to, by default, we want to do what the default is, which is to draw the whole image. But we're going to draw the destination is going to be now what we defined the image rectangle to be on the screen. So we'll flip it as before. And then the only other thing we want to do is update our X and Y positions. X pos plus X velocity, Y pos equals Y pos plus Y velocity. So what that's going to do is every frame after we flip, it's going to update the position on the screen, then we update the rectangle that we're drawing into, and then we draw the next frame and flip it. Okay? So let's see how that works. I know this is probably going super fast, but I just want to show you some of the things that are possible. And we'll get into, oh, it worked for a second. So what did I do wrong? Anybody have an idea? I sort of deliberately made that happen. So what's my problem? I mean my problem in my code. Anybody got an idea? What did I not do, or what did I not take into account? Well, it flew off the edge of the screen, right? So I'm adding a pixel value to the current pixel value every time, but there needs to be some way to say, oh wait, if your pixel value gets bigger than the screen, you need to go bounce back the other way, right? So we can easily do that after we update the X and Y position. So we've already got the minimum and maximum coordinates on the screen. So we could say something like, if X pos is greater than X max, and actually if we're really smart, we can do this all in one if statement for X, or X position is less than X min. So that means if the position goes off the screen in either the left or right directions, we can just say X velocity equals negative. So you can just say negative X velocity. So it's going to become the negative of itself, which means now it's going to go in the other direction. And then we want to fix the fact that it went too far, so we're just going to update it a second time. X position equals X position plus X velocity, which basically means now we're adding it on back in the negative direction. So that should flip the sign of the velocity every time the X position gets too big or too little. And if we just copy and paste that code and replace all of our little X's with little Y's, we should be able to do the same thing with the Y direction. So Y velocity, Y position. All right, so in theory, that little addition should be enough to give us a nice little screensaver that's very simple, but very simple little screensaver, but that you know, if you can hear my fan, is taking up like all of my CPU because we're running it at 60 frames a second. But you know, that's kind of cool that you can do that, right? So as you can see, like you had to know a bunch of things that I know, but you guys don't know yet. But that's not that much code to do this, right? That's 49 lines of code. And one cool thing is that, you know, once you've got the basic code to draw this, you can add in all kinds of other features. So, for example, if we go back to draw texture, I mean, the nice thing about Psychtoolbox is that, and this is true of PsychoPy too, but I think it's a little harder to do some of this stuff, is it can do basically anything your graphics card can do. So if we wanted to, like, say, rotate, have a rotation angle, so if we want to rotate this as it spins, or sorry, as it moves, all we have to do is add in a couple of variables to say, like, let's say our rotation velocity, so how fast it rotates, let's make it 1, and the unit will be in degrees per frame. Let's add a variable called current rotation or something like that. Start it out at 0 or something like that. And then every frame when we update the position, we'll also update the rotation. Current rotation equals current rotation plus 1. So every frame that will increase the number of degrees of rotation by 1 degree. And the only thing we have to do is change our draw texture. So now we give it a window pointer, a texture pointer. We skip the source rectangle. We tell it what destination rectangle. And now we need to just also give it a rotation angle, which will be current rotation. I'm saving after each time, by the way, but it should warn me if I'm trying to run something that's unsaved. Hey, it's a little rotating smiley. So again, you see, like, I think the main takeaway lesson here is there's a bit more of a setup cost for using Psychtoolbox, but once you've got it, you can use some very powerful, you know, things that it can do without much additional cost. So if you're trying to do anything really complicated, it's nice because you have all the mathematical calculation resources in Matlab, you know, together with all these functions in Psychtoolbox. So we're not done yet. Let's do a couple other things. Well, we could say, what if we want to also, you know, grow or shrink this this image while it's spinning? So let's just set a couple more variables to define how much it can grow or shrink. Oh, shoot. What did I... Oh, I was a very bad programmer there. I said +1, but I should have really said rotation velocity here, sorry. Which gives the same effect because I set rotation velocity to 1. But, you know, the difference is now I can just change this to, like, let's change it to 10 if we really want to drive that smiley face nuts. Oh my god! I'm spinning so fast. Right, so that's nice because I can just change that one parameter now. All right. Should have set this to a slightly shorter time for all these quick little demos. I think it's only set to, what, 10 seconds? Oh, it's set to 20 seconds, so let's set it back down to like 10. Okay, so let's do a couple other things, like I said. So let's make it grow and shrink each time. So the only thing that we want to probably do here is, I was saying I had a bug in the first version of the script, and my growing grew out of control. So we don't want to do that. So we want to have let's have a max height. Let's do it by height. Equals, let's say it's 2,000 pixels. which is actually bigger than the screen, but that's actually okay. You can draw off the screen and Psychtoolbox doesn't freak out. And let's set the minimum height to like 10 pixels. And now the only thing that we need to change is, and we have to have a scaling velocity, or how quickly it resizes. And it's going to be very small, actually. This is in basically a proportion. So this is saying that every frame it'll get 1% bigger or smaller. And we'll add in a couple other things. So there's a so what we'll want to do is update our image rectangle. And again, there's a nice little built-in function in Psychtoolbox called scaleRect. There's a whole page of weird little functions you can do on rectangles. I'll find it later. But you can look all these up in the Psychtoolbox documentation. They've got a million different subfunctions for rectangles and all kinds of other things. So we want to rescale the rectangle, image rect, and we want to scale it. Well, let's actually look it up quickly. So, whoops. Oh, there it is, scale rect. All right, it just tells us what we want to give it, a rectangle and a horizontal and vertical scale factor, right? So in this case, it'll be the same for both dimensions. So it'll be image scale velocity, image scale velocity. Actually, let's run that the one time and just see it get out of control a little bit. Oh, let's turn the rotation speed back down because that will make us sick. Rotation speed, let's go to 1 degree per frame. Okay, so this will, now what we've done now is only increase the size, right? Which is, all right, it kind of makes you feel like you're going insane. But we didn't have anything to like make it get smaller again, right? So it's sort of like bouncing off the screen in the sense of we didn't say to ever get smaller again if it gets too big. So what we need to add in is a couple more of these if statements like we had for bouncing off the sides of the screen. So we can use, again, a nice little function called rectHeight. Although, again, rectHeight is really just the top minus the bottom. So it's a simple little function. But Psychtoolbox has a function called rectHeight. So if the height of the image rect is greater than, what do we call it, image max height, and this is a little thing that we don't have to worry about why this is true, but we want to make sure that if it's too big and the velocity, basically what we're going to do is, if the velocity is greater than 1, meaning we're scaling it up, we're going to say the image scale velocity is 1 over itself, which will basically make it like 0.9 something, which means it'll start scaling it to 90-something% of its current size. So we'll get into the mathematics of why you want to do that. And again, we'll just rescale it once like we did to undo the overscaling. This is getting into some finer points. This is really just illustration here. And if we want to make sure that it's too small, we also want to flip it again so it's now greater than 1. That's fine. So this should now make it start shrinking again once it gets too big. Although I think I set it to get pretty big, so. Okay, but see, now it started shrinking again. Let's actually make it go a bit longer and decrease the max height a little bit. So let's make it 1,000 and make it go for 20 seconds. Okay, so it gets bigger, smaller again. So, again, this is not particularly useful, but I think it shows you like all the stuff that you can do with something like Psychtoolbox with a relatively small number of lines of code, right? Because we're up to about 60 lines of code, but we were adding them just 2 or 3 at a time and kind of copying and pasting a lot of it. So that's not too hard to do once you've got the basics down. Let's do a couple more quick little things. Well, just to prove that you can do this with other images, I brought in a couple of guest stars, again this time, like we did, I think, last semester. So, if you wanted to animate a different image, we could certainly do that, right? So let's just see what it looks like if we use a human, like our fine dean of science. Oh, so look, there we go. Got a nice floating, rotating head. That's fun. It's a little disturbing, actually. But it'll get more disturbing. Watch this. And if we wanted to do something like, instead of the image itself, if we wanted to do like the color inverse of the image, that would also be really simple to do. We could just say my image inverse. You don't have to know the details of this right now, but basically the values in an image go from 0 to 255. So if you want to flip it to its inverse, you just say 255 minus my image is the inverted image. And then let's draw the inverted image instead of the main image. Let's see, where do we actually draw? Oh, so when we make the texture, let's make it with my image inverted instead of the image itself. Making this gradually more horrifying. I'll change it to me so that I'm not just picking out Peter. Those are the images that I had from last time. Although Peter's eyes are glowing really awesome in this one in a way that mine aren't, I think. All right, so we'll change it back to me. And if you want to do something even crazier, you could do something like make two textures, one for the main image and one for the inverted image. So my texture, let's call them my texture and my texture inverted. Let's say we want to like flip back and forth between those for some reason. You could do that pretty easily. So all we'd have to do is put an if statement here and decide which texture to draw. So like, let's say we'll flip like every 6 frames. So I won't ask you exactly what this means right now, but I might do this on a problem set or something like that, ask you to step through some of this code that we're just doing quickly now. So every like 6 frames, draw the main texture, but every other 6 frames, draw the inverted texture. We can make this really terribly disturbing. Let's up the max size again. Make it really horrible. Okay, so now you've got flashing disco psycho me coming at you. So you can do fun stuff like that, right? So not all that useful, but again, the point is here, you've got a lot of power, right? The downside of all this power is that there are a million different functions in both Psychtoolbox and Matlab, right? So if we go back to the main Psychtoolbox documentation, these are all the sections. These aren't the actual functions. These are the sections of Psychtoolbox documentation. So you've got a lot of stuff in your basic routines, stuff for dealing with files, stuff for, little one-liners, which are like small functions that do simple things, things for dealing with rectangles. I was telling you about those earlier, right? So you can align 2 rectangles, you can center one rectangle in another, you can get the top or bottom, you can scale it by a factor, which we were just doing, things like that, right? You can do all these simple little functions like, tell whether your computer's OS X or Windows, which is sometimes helpful, a million other things. And then all these things like we just talked about, I briefly talked about getSex. That's going to be very important for getting the current time. All these keyboard functions, a lot of the stuff you're going to want to use is in the PsychBasic, right? So these are all functions in PsychBasic, and then, the mother of all functions is the screen function that you do all your drawing with. And screen, as you can see, all these little red strings are the subfunctions of screen. So there's a million subfunctions of screen. So the advantage is there's a million functions in Psychtoolbox, and there are a million other functions in basic Matlab, right? So, you don't have to write a function to read a file from the disk because you've got this imread function. The downside is you kind of have to know that these things exist. So in a sense, you kind of need like a bit of a native guide to help you through this stuff, which is going to be me for you guys. But one thing about Matlab and Psychtoolbox especially is like you never really learn it all, right? Like there's so many functions that not everybody knows all of them. So like my friends who use Matlab and I are still finding Matlab functions all the time that we didn't know existed that make our lives easier. Because you can't just like read through a giant list of them because there's so many. So anyway, we're going to work at learning some of these. Hopefully that shows you some of them. I'll quickly publish this code to the Google Drive if you guys want to play around with it some. Now that you know, remember the secret incantations are Control-C to stop your script running, SCA to clear out your screen, and then you'll probably want to call this PFP PTB cleanup to basically, it clears out your memory and anything else that got screwed up from crashing Psychtoolbox. But I'll let you guys play around with this. I know you haven't really had the chance to code any of it up yourself, but we'll do a little bit more of that next week and in problem set 8, the one after this. Okay, so any questions about anything? Okay, cool.